All right, we're looking at our code here that we left off with, and it's our Beam Internet 1, and we have our approximate solution here and our finite element, our exact solution, our finite element. You notice the stair-stepping shear, not supposed to be stair-stepping. Notice the moment, and then the deflection. So the deflection, when I copy it over to here, it's looking pretty decent. Now what I want to do is go back and put a spring load in here. Now what you notice down this left side is I have all my variables right there. So what I'm going to do is hit the word clear, and notice they all disappear from over here. And why am I doing that? The reason I'm doing that is I have decided that I need to put a load at one of these locations. So here's my nodes, here's my force. As it turns out, it looked to me like my node 1 was at distance 0. So if I'm truly putting this point at distance 10 over, I've got to pick node 6. I'm going to pick node 6, and I'm going to put 100 times the ELTA. Now if I run this code, first thing you notice is it says delta is undefined variable. Run it as much as I want, it's always going to do that. So here's my problem. What is delta? Well, in my first run, I could pretty much say it's 0. However, when I run it the first time, one of the problems here was I did a clear. I'm going to go ahead and put a comment there. Go back and put our delta out here. Now I'm going to hit run. I should get a solution. Okay, the first thing you see is something weird happened here. I'm not sure exactly what, but I may have, let's take a look and make sure I didn't do this wrong. Oops, I put it on the wrong location and did a node slope. Oops. I'm supposed to be putting a force there. So I goofed that big time. I should have put the node in the force. So here, copy that, put it right here. Oops. So, I don't know what I was thinking. The node in the slope is the cantilevered part. Now let's run it again. Okay, now I got it back. Put it in the wrong place. I'm supposed to put it down here on the force. Now what you notice is the deflection. He says it's 0, goes all the way down to 100. That's a pretty large deflection, but in fact, if you look here, we need to pick off this number, multiply it times 100, and put it right back in here. So the key is I need to go down in here where this is produced and pull this off. Okay, so that's what I'm about to do. I'm about to run down through the code and look at where he puts this value out. So I'm looking for the node, distance, so on and so forth. So here's what I'm going to do. I'm going to stop it right here. I'm going to run it. It stopped right there. I'm going to step it. So you notice it already printed the value. So now it's doing the values. Concatenated string, then I display the string, so I display all this, and this is the local shear on both ends. Now I'm going to go through the nodes. Now what you'll see, I'll do a step. So when I get to this particular point, I'm going to put a break point. I'm going to do a continue. So I got node 1. So there's your I. Let's continue to node 2. Now the deflection turns out to be this variable right here. If you notice, your node gets put right here. That's right here. Then your distance right here. That's right here. This one becomes your deflection. So what I'm going to do is I'm going to grab that one, do a copy, head up under here, and just say spring loading on node 6, I believe it was. Delta equal to. Now if I grab this and I put this in right here, all I have to do is put in 6, and let's try it. Hit the F9 or right click, evaluate the selection. I get 35. Tell you what we want to do. I want to save this. I am going to put a breakpoint right here on it. I'm going to run it again. So I'm running the code, and is the value, okay, now I got 33 this time. Is this the case? Okay, let's do a step. Hover over this, and I've got 68. I'm sorry, I misread that. It's node 6 right here. It's 68. Sorry about that. So the value is of the deflection is 68. Oh, and apparently it's supposed to be 100. If I continue on, let's continue, I get a much larger deflection. Let's see if we can remedy what this problem is. There could be a variety of problems. Here's what we're going to do first. I am going to clear everything. I'm going to go back and put delta is equal to 0, and I'm going to run the code. First time through. Okay, it's right, it's 100. Is delta going to be 35? Yes. So let's continue this all the way through. Okay, so there's our deflection. This time I'm going to run back through it with delta. Okay, so I get 168. Now, problem is the sign. Okay, I've got a negative deflection here. I wanted it to push up, so really this force should be listed with a minus sign. And so let's see what happens here. All I have to do is continue it and continue it again, and I should eventually reach a point, possibly, maybe, where I reach a converged state. It's not looking very likely. Maybe it is now. Okay, looks like it took a while to get there. Okay, I'm finally, as I hit these things, I'm looking at the deflection. Bounces around a little bit, but it's around 64.5. And believe it or not, I put it at the wrong location, apparently. Let me run back up. Where did I put this thing? I put the force at the wrong location. Should have been on 6. But guess what? It should still work its way through it, hopefully. Or it may be best to, here, clear, and then just say delta equals to 0. Then run the code once. Looks to me like I'm going to make the code explode here. So yeah, I'm running out of control here. You can see it constantly growing here. Okay, let me show you what I did here to make it a little bit more realistic. What I did is I went in and changed my modulus to 1 times 10 to the 6, or 1e to the 6th. And I decided, since it'll be a square section and be a 1 by 1 section or something thereabouts, I'll go ahead and make the modulus or the beam property be this. However, if I did decide that I wanted the height of the beam to be 1 and its thickness to be 0.01, like in the 2D case, I might opt for this. So I think that's what I'm going to do real quick. I'm going to make a change, and I'm going to replace it with this. Okay, now I've got a different, I've got a modulus of 1 to the 6th. I've got this, and the reason I'm doing this value over 12 is it's 1/12 base times height to the 3rd. If the height is 1 and the base is 0.01, then I can do a thin beam inside the 2D to validate this. Here's my load across the top. What I've done is I've put 100 times delta. Now delta ends up getting defined right down here. So there's where your delta gets defined. Is the spring loaded on node 6 in this case. So what I'll do is I'll do a clearing all the variables out. Delta equals 0. The initial deflection is 0. I'll run the case. Looks like wait a minute. I didn't wrap up a couple of issues here. I've got E over 12 down here. Maybe I better just stick to that. Okay, I'm going to go ahead and stick to the 1/12. So sorry about that. I'm going to go ahead and stick to the 1/12. Okay, that'll match the exact, or not the exact solution, but the first run through it will. Okay, clear it out. Delta is equal to 0. First time through. Run it. First time it should end up being okay. Second, third. So pretty soon it stays stable. It doesn't change anymore. The deflection in this deflection column right here and the slope column, and I guess the force and the rest of them as well, they don't change anymore. So it's pretty much converged. I'm just keeping hitting it. If you go down in here, what you'll find, if you found delta in this, you'll find here's your deflection, which should be the value that sits right here, and we're okay. So I'm going to put a video right behind this that basically supplements this to basically say what we did here. What I will also do is save this on the Google Drive as Beam Internet 01 Spring, and I'll bring up the old one. Bring up the old one and take out that force. This force is not there, and for that matter I don't need to find delta anymore, but I'll go ahead and take it out. This line right here is no longer needed. Okay, so this is the old case, and it just gets you the exact solution. The one with the spring, however, is this one, and it gets you the solution. Here's the exact solution without a spring. At 10, the deflection that I took, it got pushed up. There's a force pushing up right here, and you can see it over here in the shear that essentially made the beam deflect less. What I'm going to do now is, in the next real short video, I'm going to subdivide it or show you exactly what problem I just solved, and then I'm going to go in and do it in 2D.